Hey everyone, let's tackle page 4 of the 6.2 notes, which are the problems in reverse. So you're given the ratio and you have to find the angle. So these are where if you're going to use your calculator, use the inverse button, right? So this first one, S is just going to equal sine inverse of 0.7425. And again, make sure you're in radian mode because it's specifying radians here, not degrees. So let's jump to the calculator for that and try it out. Okay, so this was from last time. Let's clear. Okay, so just a second. Make sure it got that sine inverse function. All right, and then 0.7425. That's it. Okay. And that'll give you the angle in radians, right? So this one, oh, we got extreme round decimal places, 8 of them. Great. Okay, so whatever that is, rounded to 8 decimal places, and we're good. So the other one, cosine inverse of the same thing, some angle, some ratio, and you're going to get the angle. Cosine inverse 0.4395. That's example 17 in the handout. And then there it is. Okay, so just carry it out to the correct number of decimal places, and you're good to go. Okay, so that's it. And then let's try some where you have to use the unit circle. So I'm going to go back to the handout and take a look at those. So let's look at that first one. Sine negative root 2 over 2, and you want that angle between pi and 3 pi over 2. So if you think about pi and 3 pi over 2 where they are, that defines quadrant 3, right? And sine, remember, is the y coordinate. So look in that quadrant 3 on your unit circle where there's a y coordinate of negative root 2 over 2. So I can go back up to that unit circle. And that is right there. There's a y coordinate in quadrant 3 of negative root 2 over 2, which leads me to the right answer, the angle in radians, 5 pi over 4. And that's all you got to do. Okay, so this one would equal 5 pi over 4. And that's the angle S. So you can do the same thing for 19. The angle is going to be in quadrant 4, and you're looking for an x value because it's cosine of 1/2, right? So quadrant 4, where there's an x coordinate of 1/2, whoops, I meant to highlight that right there, right? And that leads you to the angle 5 pi over 3, okay? How about that last one? Tangent negative root 3. Remember, tangent is y divided by x. So you want that ratio of y over x to be negative root 3. And that's quadrant 2, right? Between pi over 2 and pi is quadrant 2. So let's look for a ratio of y over x as negative root 3. Right? So this one's a little trickier, right? See how this is between, so pi over 2 is here and pi is here. So that's that quadrant 2, right? And we're looking for, again, a ratio of y over x that is root 3. So really what I'm looking for is I want the y to be root 3 and the x to be 1, and ignoring denominators because I know they'll cancel in that ratio. And that leads me to these guys right there, right? Root 3 over negative 1 leads me to that angle, 2 pi over 3, okay? And so that one would be the final answer, 2 pi over 3. All right. That's a good quick stopping point. So just wanted to knock out that page 4 real quick, and then the next handout I'll do the rest, which is all on applications, linear velocity and angular velocity. Okay. Talk to you later.